In this video I'm going to look at the January 2012 F324 paper, and I'm looking at question 2. And in terms of topics being tested, it's predominantly about benzene. So the first part of the question deals with a 3-stage synthesis, starting with benzene, and benzene is ultimately, I'm just going to have to push the question up here, benzene is ultimately converted into 4-chlorophenylamine, and so we've got to suggest reagents, conditions and the organic products for stages 1 and 2. So in terms of a route through this, I ultimately want to get a chlorine here and an amine group here. So the way I'm going to do that in stage 1, I'm going to put the chlorine on by reacting the benzene with Cl2, and I'm going to use an AlCl3 halogen carrier catalyst. You could also use FeCl3. So that's that part done. I now need to get the start the process of getting an NH2 group at position 4, and so the way I'm going to do that is I'm going to put a nitro group on first. So that's reacting this organic product with the nitrating mixture, so that's conc nitric acid and concentrated sulfuric acid. And then once we've got that on there, we can reduce it to the amino group using tin and conc HCl. And of course you could do it the other way around. The next part of the question is about azo dyes. So it's saying that the 4-chlorophenylamine can be converted into a diazonium ion, and then that can be reacted with phenol in aqueous alkali to form the azo dye. So we've got to come up with the structures of the diazonium ion and the azo dye. So the diazonium ion looks like this. Remember, we need N, triple N, with the positive sign on the first nitrogen. Because they've asked for structures, I would be drawing the full displayed structure there. The azo dye, so if you reacted this with phenol, you'd obviously get this molecule here, and again I'm clearly showing the structure in the azo dye with that N double N now. The next part of the question is getting us to apply our knowledge of the electrophilic substitution reaction with something we're not familiar with. So SO3 is not actually specified on the syllabus, and yet here it is in this question. So just apply your knowledge of what you do know, and hopefully you'll see that this is identical to all the ones that are on the syllabus, so nitration, halogenation, etc. So we've got the electrophile with its dipole already drawn on for us. So we're going to have a pair of electrons from the pi electron cloud attracted to that sulfur, and that will repel a pair of electrons in the double bond onto the oxygen. That will generate this intermediate. So we need to draw this partial pi electron cloud, and so we need to cover 5 carbons. So I sometimes call this the horseshoe. Don't forget the positive sign in there. And this bond here has become a single bond, pair of electrons up there now, and so we've got this negative sign here. We show the hydrogen now because we need to draw this curly arrow from the middle of the bond, pair of electrons going back into the ring to reform the pi electron cloud as it's been shown there. Part C is testing our knowledge of reactions of functional groups, and they're using paracetamol to test us, and so it's saying separate samples of paracetamol react with bromine. So you can see I've written up there, bromine's going to react with the benzene ring, and then sodium well, that's going to react with this OH group of the phenol. So we need to draw the structures of the organic products, and so because it's not just a benzene, it's actually a phenol. Remember when phenol reacts with bromine, we get tri-substitution at positions 2, 4 and 6, and so I will just mirror that here, but you can see position 4 is taken, so I've put bromines at 2 and 6. The reaction with sodium, the hydroxyl group of the phenol is going to react with the sodium, and we're going to get this phenoxide group here, so that's O minus, Na plus. Be very, very careful, don't draw a line there, because that makes it look like that is actually a covalent bond, and that would be wrong. This is an ionic group here. The very last part of the questions testing our knowledge of hydrolysis reactions, and so the paracetamol is being hydrolyzed by heating under reflux with hot aqueous sodium hydroxide solution, and we've got to come up with the two organic products formed. So the first thing to note is the bond that's going to break will be this one here. Now, because we're using aqueous sodium hydroxide, we don't get carboxylic acid here. This will become a carboxylate salt, so we're going to get O minus Na plus on the end here, and this part of the paracetamol, well, the NH will become an NH2 group, so you can see that there, but beware, we've got an OH group here, and that will also react with sodium hydroxide just like it did with sodium, and so we're going to get the phenoxide again, this sodium phenoxide group, so O minus Na plus.